Hi everyone, today we're going to have a little bit of a different type of video. Up to this point, a lot of the videos have been on writing code, and we've been doing some mid-level stuff with C++, but then a fair amount of low-level stuff with assembly. Today we're going to talk about something that seems pretty simple, and that's electricity, the stuff that makes all of the magic of programming actually work. And often, when you think of electricity, you might think of a lightning bolt, things like that. And the purpose of this video really is to try to find a way to describe electricity. And if you're anything like me, you're wondering, how does it work? What actually makes electricity work? And you heard things like its flow of electrons and its magnetism and waveguides and in actuality, we don't exactly know what electricity is. So let's talk about something that we do understand. How about water? Um, so if you're a normal person, you probably, when you hear the word water, you think of something that's clear, that it's a liquid. You can pour it into a glass. If you heat it up and make it hot, it'll boil, and if you make it cold, it'll turn into a solid, and we call that freezing. The things you probably didn't think of is when you heard water, you probably didn't think of um, hydrogen and oxygen combining on a periodic table. Now, if you're a chemist, you might have thought of that. You might have thought, well, obviously it's that. If you're a physicist, you might have thought, oh, there's some quarks going on in there, and it's made out of subatomic particles that are driven by quarks. If you're a biologist, you might have thought about how water affects cells, but hopefully you're getting my point here. A normal person, when you think about water, you don't think about what it's made out of. You think about what normal things does it do that apply to you in your life. It's it's nice to drink when it's cool. If it's hot, it'll burn you. It bubbles when it is boiling. It gets solid and it will float on top of liquid water when you freeze it. Um, Temperatures might come to mind of how to measure the temperature of the water to determine what type of state it's in. Um, these are just the normal things that I think we all kind of think of. So let's think about the basics of electricity. Well, ironically, we can compare it to water. Water, when it's going through pipes, has pressure and it has a volume. And by this broken pipe, we can see there's a lot of volume coming out of there, and it looks like there's a pretty decent amount of pressure as well. And when you are talking about electricity in a circuit, you have voltage and current. Voltage being basically synonymous with pressure, and current being the flow of the amount of electrons that you actually have there. Or when you run it through a coil, the amount of magnetism it'll generate. And when we're talking about circuits, we have conventional flow, which is things flowing from the positive side going to the negative side. Now, this is the opposite of electron flow. Electron flow, which is what you would have learned in physics, is the electrons move from negative to positive. Conventional flow is positive to negative. So if you know nothing about physics, you're probably off to a good start, which is ironic, isn't it? Um, so when discussing wires, we have current that can travel through the wires, or I should say, electricity can travel through these wires, these conductors. And then there's insulators on the outside, which electricity doesn't really like to travel through. However, just like water likes to travel through the pipe, if you have a high enough of a pressure, you can actually rupture the pipe and it will escape out of the pipe. And in the case of voltage, it will actually go through insulators. And that's why if you have extremely high voltages the wires need really, really thick special insulators on them, like for ignition wires on cars and things like that. The electricity will try to escape the wire, basically. Um, and when we're thinking about the current aspect of it, if there's basically no current, there's pretty much no electricity there, but it's really high voltage. We call that static electricity. And yeah, that will jump through the air. Air is normally a pretty good insulator, but if the voltage is high enough, it will travel through it. And if the current's traveling in one direction, like we have in our little diagram here, that's called direct current. It's directly going in one direction. And if it alternates back and forth, we call that alternating current. So those are basically the three types of electricity, and primarily with electronics, you're going to be looking at alternating and direct current. You're not going to necessarily be thinking about static electricity other than if you touch a chip and you get a static discharge on it, you might have just broke the chip, which is never a good thing. And then, just like with water, you think about what things does it do for you. You can drink it, you can cook with it. So what does electricity do for us? Well, there are different byproducts. One of them is heat, and heat is not always a bad thing. If it didn't make heat, your toaster would not toast bread for you. Magnetism is another thing that it can generate with electromagnets. You can see a little example there using a nail with a battery. And then there's radio frequencies. So you can think of radio being able to send out radio waves. And ironically, when I was thinking about this, I included the light bulb for radio frequencies. And the reason for that is our good old fashioned light bulb like that. What it's actually doing is the electricity is traveling back and forth at either 50 or 60 hertz, depending on where you live in the world. And it is making that filament so hot that it glows. So the electricity, it's producing heat, and that produces the light. But by going back and forth in that wire at either 50 or 60 hertz, it is actually transmitting a radio signal, basically. Whenever electricity is moving back and forth in wires, it creates radio waves. So that's kind of an interesting thing. And then lights would be more or less like an LED and things like that, where it more directly generates light. The light bulb, you need it or else you don't get light, but the electricity isn't actually being like converted into light or anything like that. And that's all I had for you. Very simple video. Just what are the basics of electricity, and not coming from the standpoint of electrons moving through wires and trying to explain how and why that works, or how magnetism is involved, other than that it will create it if you create a coil of wire, and not trying to get into subatomic particles and complicated stuff. Just from a high level point of view, it's voltage, it has amperage. What does it do for you? It makes heat, it generates magnetism, you get radio frequencies, you get light. These are the different things that your circuits actually will do. Or in some cases, they'll do them and you won't want them to do it, like heat. That can become a problem sometimes. So that is it. I hope you enjoyed this video, and I hope this was a good introduction into electricity, and now we'll start to move into electronics things. So we look forward to seeing you in that next video.